Hello students, welcome to Educate. Today we are going to study conservation of linear momentum and other related aspects in 11th physics. So you know what is momentum? I think you remember momentum is P, which is mv, and here our purpose is to show that in absence of any force, momentum remains constant. So if you consider dp upon dt, change in momentum per unit time, what does it represent? So d upon dt of m times v, that is d upon dt, m is constant, you can keep it outside, then dv, and dv upon dt is acceleration. So you get force dp upon dt equal to ma. So here we write F equal to dp upon dt. Now suppose F is absent, there is no force, so this will be 0. So we get dp upon dt equal to 0 or p equal to constant. Now there will be a question in your mind, if dp upon dt equal to 0, then why p equal to constant? So let's understand it. The logic is simple. As I have told you in differentiation, that d upon dx of x power n equal to nx n minus 1. D upon dx of 5x gives 5 times dx upon dx, that is 5. But d upon dx of constant will be 0. In our question, what we have got? When f is 0, we got dp upon dt equal to 0. This is same case. D upon dx of constant equal to 0. Here differentiation is 0, it means p must be constant. So that is why we say p is constant. So conservation of linear momentum states that in absence of any external force, the total linear momentum of the system is constant. Let's read it here. If there is an isolated system of n particles and masses of these particles are m1, m2, m3 till mn, and they are moving with velocities v1, v2, v3 and vn, then total linear momentum of the system is given by p equal to m1 v1 plus m2 v2 plus m3 v3 plus dot 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 plus mn vn. In absence of external forces, I told you dp upon dt must vanish, which gives p equal to constant, or we can write this term m1 v1 plus m2 v2 plus m3 v3 plus mn vn equal to constant, or we can also write p1 plus p2 plus pn equal to constant. So I think you have understood. Now, on the basis of knowledge so gained, we are going to see some example and we will do some numericals, like recoil of a gun. Recoil of a gun means what? Here, before firing what is situation and after firing what is situation. So before firing, let's find out the momentum. So gun and bullet. So gun has mass capital M, bullet has mass small m. Velocity before firing, say this is u1, which is 0, this is say u2, so it is 0. So total momentum before firing will be m times 0 plus m times 0, which is 0. After firing, what happens? Suppose after firing, gun has velocity v and the bullet has velocity small v. Then what happens? momentum after firing. So it will be mv plus small mv. But according to momentum conservation principle, in absence of any external force, total momentum must remain constant. It means momentum before firing must be equal to momentum after firing. Before firing it is 0. So after firing it should be 0. So we can say mv plus mv is equal to 0. And if we want to find out capital V, so minus mv divided by capital. So this is the recoil velocity with which gun will move in backward direction, or the person who is holding the gun will feel a jerk. The same thing is explained here. If you read it carefully, when a gun is fired, the bullet is accelerated forward with a certain momentum. According to the conservation of linear momentum, the gun must experience an equal and opposite momentum in the backward direction. That is called recoil, to maintain the momentum conservation. And to mitigate the effect of recoil, the shooter must hold the gun tightly against their body. By providing firm grip, the shooter reduces the ability of the gun to accelerate backward, thereby minimizing the recoil force. Here, before firing, after firing, it moves backward, the bullet moves forward. So it is very clear. As I told you, mathematical explanation, the same thing I'm reading. Let mass of the bullet be small m and that of then is capital M. Initially both are at rest, so initial momentum is 0, and when they are fired, the total momentum comes out to be this much. And since momentum remains conserved, so we can say that capital M capital V plus small m small v gives this much. So we are going to get recoil velocity capital V equal to minus mv upon m. Negative sign shows that gun recoils. Now, here there is a question for you. From the following data, calculate the recoil velocity of the gun. You are given mass of gun 10 kg, mass of bullet 50 grams, speed of bullet 400 meter per second. Then recoil velocity of the gun is to be found. Formula you know very well. Capital V equal to minus mv upon capital M. When we put the values, we can get the answer. So I'm not doing it. That is for you. Another example. Jumping out of a boat. When a person jumps out of a boat, they exert a backward force on the boat due to their forward momentum. According to conservation of linear momentum, the boat must experience an equal and opposite forward momentum to maintain momentum conservation. To prevent the boat from moving forward significantly, the person must push against the boat with sufficient force while jumping. So this you have understood. Later on you will read rocket and jet planes, same happens. I'm not going to read them. Then you are given this question. A 40 kg shell is flying at a speed of 20 meter per second. It explodes into two pieces. One of the two pieces of mass 15 kg stops. Calculate the speed of the other. So here momentum before and after must be conserved. So in the beginning, say mv capital V must be equal to m1 v1 plus m2 v2. So mass is given 40 and velocity is given 20. 15 kg comes to rest, so it is 0. Then remaining 40 minus 15 is 25 kg will have certain velocity. So our concern is to get a v2, so we can calculate 40 into 20 divided by 25. This will give the answer. Now we are going to see equilibrium of concurrent forces acting at the same point, and if they all are in equilibrium, means suppose this is an object on which the forces are acting and the object is not moving. In that case, we say that these are concurrent forces. Okay, so here one theorem which is pertinent at this level, that is Laby's theorem. It says that if you take force, suppose here you have taken, this is F1 force and angle opposite to this is say theta. and this is say force F2, angle opposite to is say this is phi, and suppose this is force is F3 and angle opposite is psi. Suppose this is psi. Then rule says force divided by sine theta of angle opposite to it is sine theta must be equal to, take F2, so F2 then sine phi equal to F3 divided by sine psi. So this is the rule, this is the statement of Lamy's theorem. We will learn its practical use while solving numericals. Here same thing is given, F1 divided by sine alpha. In this case, here F1, alpha is in this direction. Similarly, if you are taking F2, then you have to take sine beta. If you are taking gamma, then if F3 force is taken, then gamma, so sine gamma. So they are equal. Now, we are going to analyze some questions. Here, we are given this is 6 kg weight in downward direction. Here, tension is 50 Newton. Now, what is the question? A body of mass 6 kg is suspended by a rope of length 2 meter from a fixed support. A force of 50 Newton in the horizontal direction is applied at the midpoint of the rope. What is the angle the rope makes with the vertical in equilibrium? So situation is shown here. Either we can draw the graph here also. So this is rope, and here at this point one force is applied in this direction, that is 50 Newton, and then here there is 6 kg weight mass, so you can write it 60 Newton taking G equal to 10. Other situations we can discuss. Here the component of this force, so you can write like this. Suppose this angle is theta, so this angle will also be theta. Now we can imagine that tension in this string is say T1. So we can take its components. One component will be in this direction, so it will be T1 cos theta. Another component will be in this direction, that will be T1 sin theta. Now, in our question, we have to find out what is theta. So if this point is in equilibrium, then we can say that this force T1 cos theta must be equal to 50 and T1 sin theta must be equal to 60. Now it is simple. We just square the two. So T1 square cos square theta plus T1 square sin square theta will be 50 square plus 60 square. Then T1 square will be equal to 50 square plus 60 square, and then after that we can find T1 by taking square root. So I think thing is clear. Once again I am going to tell you. So here this is 50 Newton force which is acting in this direction. Here 6 kg weight is acting downward. Kg weight means multiplied by 10 Newton. So downward force is 60. Here it is 50. Now at this point, because we have to check the equilibrium of this point, so for this we take the component of this tension. So one component, if this angle is theta, in that case it depends on you. Choice you can make. If you are making this angle theta, then this term will be T1 sin theta. If you are making this angle theta, in your question they are asking that vertical angle in vertical. So it's okay. That does not matter. If you take this angle theta, then this will be 90 minus theta, and you can easily resolve. So as I told you, here if this angle is theta, then this component will be sin theta and this component will be cos theta. Since point is in equilibrium, so you can say that T1 sin theta is equal to 50 and T1 cos theta equal to 60, and then you can solve it. If you need theta, you can easily get For getting theta, what I have done, I have evaluated tension. But after that, if you don't need tension, in that case, just do one thing, just divide these two. So sine theta upon cos theta will be 5 by 6, then theta equal to tan inverse 5 by 6. That will be your simple answer. But in some questions, you will also get that you have to evaluate tension. So you can easily do that. So there is no problem. Now, another question you can see here. This is, say, tension is T2, angle is beta, and here this angle is alpha, say tension is T1. And now there is one weight here. Suppose weight is mg. Now again, this point is in equilibrium. So in order to be in equilibrium, what we have to do, we have to take the components of different forces. So draw vertical line, draw horizontal line, and then this is T2. If this angle is beta, this angle will also be beta. In this direction, it will be T2 cos beta. In this direction, it will be T2 sin beta. So over T2 sin beta. Now for this, if this angle is alpha, this angle will also be alpha. So this will be T1, and then this base angle cos alpha, and here in this direction T1 sin alpha. So situation is like this. I'm writing it clearly at this point. In this direction, it is T2 cos beta. This is T1 cos alpha. In this direction, here it is T2 sin beta plus T1 sin beta, and both are balanced by weight mg. So you can write T1 cos alpha must be equal to T2 cos beta, and then you can write T1 sin alpha plus T2 sin beta must be equal to mg. So you have got two relations. Here, after that, question says you can take m as 5 kg, alpha as 30 degree, beta as 45 degree. You can evaluate the tensions, find the tensions in this. It is so simple, I think you can easily do. Here equations are created, you can solve, you know very well how to solve. Now let's take another question. Here again the same situation is shown. Here this is rod, and there is, this angle is 90 degree, and this is P, this is Q, and this angle is 30 degree. Suppose we take, this is R. Here like tension, like forces are represented by P and R, and here downward, here weight is given. It is 60 kg. So you can say 600 Newton. Now what you have to do, you have to resolve it into components. So it is very simple. Draw one line. This angle will also be 30 degree. So component of this R, you can write in this direction R cos 30 degree, and one component will be in upward direction R sin 30 degree. And now what you do, just write the components horizontal and vertical, they will be equal. So you can say P must be equal to R cos 30 degree horizontal, and vertical is 600 must be equal to R sin 30 degree. And then you can solve. Now further, let's see next question. A simple pendulum is set up in a trolley which is moving with an acceleration a on a horizontal plane. What angle does the pendulum makes, thread of pendulum makes with the vertical? So here situation is shown. Again, it is simple. So the components are given clearly that mg is balanced by t cos theta and ma is balanced by t sine theta. So if you divide, what do you get? G upon A equal to cot theta. So if you need theta, theta equal to cot inverse G upon A. You can write in terms of also, it will be A upon G. So this is simple concept. Now motion of connected bodies. So here this is an important derivation. Let's derive the expression for tension and acceleration. The situation is shown. So here this is rigid support and here there is one pulley. There are two strings. Suppose here mass is m1, here say mass is m2, and we assume that say m1 is less than m2. Then what will happen? This body will move up with acceleration a and this body will move down with same acceleration since they are connected by same string. Suppose tension on it is T1. Just write T, not T1, because only same tension is there. In this direction, here also there will be tension T. Same tension will act. Now, what is rule? Motion. If motion is in this direction, then upward force will be greater than the downward force. Here, downward force will be m1g, and here downward force will be m2g. So now let's write the equations. Since net force is acting in upward direction, it means T1, here tension T must be greater than m1g and the difference will cause the motion. So you can say that T minus m1g must be equal to m1a because this body is in motion in upward direction. Similarly, what do you observe? m2g is acting downward and tension is acting upward, but a net force will be downward because m2 moves down. So we can say that m2g minus t will be m2a. I think thing is clear. Now what you do one thing, just add the two. So tt will cancel out and you will be left with g m2 minus m1 equal to m1 plus m2 times a. What is your concern? Your concern is to get a. So from here we can say that a will be equal to g times m2 minus m1 divided by m1 plus m2. So we have got the expression for acceleration. Now what we can do? We have to get the value of tension. So it is simple. Tension can be found by taking any equation and putting the value of A. So let's try. So here we are considering this equation. So tension equal to m1g plus m1a. So m1g plus m1 times a is this much, g times m2 minus m1 divided by m1 plus m2. Now let's further simplify. So if you simplify it further, what do you get? M1 plus M2 will get multiplied to this. So we will get M1G times M1 plus M2 plus M1 times G times M2 minus M1 whole divided by M1 plus M2. Now, if you open the bracket, what do you get? M1 square G plus M1 M2 G plus M1 M2 G minus M1 square G whole divided by M1 plus M2. What do you observe? Here, this term will get cancelled. M1 square G, and here M1 M2 G, M1 M2 G, so double, so twice of M1 M2 G divided by M1 plus M2. So that is our answer. If you take a reverse, we have assumed in our question, so our situation, we have taken M2 greater than M1, and if you reverse the case, then here it will become M1 minus M2 and rest thing will remain same. So any one you can take unless it is specified, and I think you have understood. Now we are going to see some more questions based on this concept. Like suppose you are given 3 blocks of masses, M1 10 kg, M2 5 kg, M3 7 kg, and they are connected as shown in the figure. If 44 Newton force is applied here, then find the values of T1 and T2. So before solving this question, let's understand the basic concept. What happens if many bodies are there? Like suppose this is one body, this is another body, then next body, then next body, and after that suppose force F is there. So here say this is M1, this is M2, this is M3, this is M4. Now first of all we have to find out what is common acceleration. So common acceleration will be given by net force divided by total mass, so that is M1 plus M2 plus M3 plus M4. So this is acceleration which is valid for every object. Now suppose you want to find out tension here or here or here, then what is rule? Suppose this we denote as T1, this as T2 and this as T3. So very simple rule. If you want to find out T1, so for that T1, the mass before it you will consider, and then common acceleration you will multiply. Mass to be pulled, so here T1 is pulling just M4 mass, not the others. So you have to take this mass only and then common acceleration, because the system is moving with acceleration A. So you will multiply by F divided by M1 plus M2 plus M3 plus M4. So you have understood. Now suppose you want to find out T2. So T2 has to pull these two masses. So in this case, if you write T2, so you will write the masses to be pulled. So M3 and M4 both are being pulled with a common acceleration again. So you will write here F divided by M1 plus M2 plus M3 plus M4. Similarly, suppose you want to find out T3. So for T3, T3 is pulling all three masses. So masses to be pulled, that is M4 plus M3 plus M2 times common acceleration. So that is F upon all masses, M1 plus M2 plus dot dot dot. So I think you have understood the concept. Now, on the basis of the concept that we have studied, we can easily find what is T1 what is T2. So here it is obvious. Suppose you want to find out T1. So first of all, you have to find out what is common acceleration. So common acceleration will be F divided by M1 plus M2 plus M3. Then if you want to find out T1, so as I told you, T1 is mass to be pulled, M1 times common acceleration. So I'm that writing again and again. Similarly, suppose you want to find out T2. So it's obvious, T2 is pulling two masses. So T2 will be equal to masses to be pulled, that is M1 plus M2 divided by into common acceleration. Common acceleration is F upon this much. So this is how you can easily evaluate. Now, let's see another question. Here, two masses M1 30 kg, M2 50 kg are connected by massless string as shown. Find the value of tension in the string if a force of 200 Newton is applied on M1 and on M2. So here, two situations are given. Suppose this is one object, this is another object, and their mass is, this is 50 and another is 30. This is assumed to be M1, this is assumed to be M2. So when they move, suppose in this direction they are moving or in this direction they are moving, so there must be a common acceleration. So acceleration will be equal to force applied. So force in our question is given as 200 newtons. So 200 divided by masses to be pulled. So that total mass they are pulling is 80 kg. So it will come out to be 2.5 meter per second square. So we have got acceleration. Now, as I told you, if force is applied, suppose on this side, right? So here 200 Newton is applied and you have to find out T1. Here it is 30 and here this is 50. So for T1, T1 will be mass to be pulled. So 30 kg is to be pulled times common acceleration 2.5, that is 75 Newton. Similarly, if force is applied in this side, in the side of 30, sorry, so this is 30, this is 50, you have to find out this tension. So here mass to be pulled is 50 into acceleration is 2.5, so it will be 125, 125 Newton. I think you have understood. Here there are certain questions for practice, like two blocks of masses 50 kg and 30 kg connected by a massless string passes over a light frictionless pulley and rest on two smooth planes inclined at angle of 30 degree and 60 degree respectively with a horizontal. Determine the acceleration of the two blocks and the tension in the string. This is good question. So let's see the situation. What is happening here? So questions you have read, once again you can read, then I will make it small. Two blocks of masses 50 kg and 30 kg connected by massless string passes over a light frictionless pulley and rest on two smooth planes inclined at 30 degree and 60 degree respectively with horizontal. Determine the acceleration of the two blocks and the tension in the string. So now let's see the situation. What is happening? So we can say that this so here there is pulley, one mass is here, say this is 60 degree and here this is 30 degree. Here one mass is there and here another mass is there. So two blocks of mass at 50 kg, 30 kg are connected by master string over pulley and rest on smooth inclined at 30 degree and 60 degree respectively. So 50 lies on 30 degree side. So here 50 kg and here 30 kg. Now this tension say T, this will also be same tension because string is same. So this is tension. Now what happens in an inclined, if there is an inclined plane, then in this direction mg sine theta will be the force that will act. So in this direction mg sine theta force, mg sine theta, here you can say 30, so say it is m1 sine 30 degree will act in this direction. Here force will be m2 and then g sine, here theta is 60 degrees, sorry, this 60, this is 30 degree. You understood the concept? Along incline, the g sine theta component of gx, because perpendicular it will be mg, but in this direction along the incline, if this angle is theta, then component of mg becomes mg sine theta. So what you have observed, that mg sine theta will act in this direction, there will be tension. Now you have to see the motion. So you can consider the motion. Imagine that object moves in this direction with acceleration a. Later on, if our assumption will be wrong, then a will be negative. That does not matter. So let's see what are the net forces. So in this direction there is tension, in this direction mg sine theta. So m we can write 30 g sine 60 degree minus tension is causing motion in a 30 kg object, so 30 a. I think you have understood. Net force in this direction, tension is opposing, so 30 g sine 60 degree. So 30 times, if you take value of g, still you can easily evaluate. Let's take it as 10. So 300 into root 3 by 2 minus tension equal to 30a. This is equation number 1. So or you can write here 150 in place of this, 150 root 3. So 150 root 3. And in this case, here tension will be larger than m2 g sine theta because body will move with same acceleration in this direction. So we can write tension minus m2. m2 is 50 times g is 10 into sine 30 sine. So let's write it for sine 30, and we are observing that 50 kg mass is moving with acceleration a, or we can say t minus sine 30 is half, so this will become 500 divided by 2, so 250 equal to 50a. Now if you add these two equations, you will get what? tt will get cancelled. 150 root 3 minus 250 equal to 50 and 30, 80a. From where you can get the value of a, and that will be around the value given in the answer, that is 0.12 meter per second square. You have got the value of acceleration, and you can put that value of acceleration to get tension from any equation. If you put here value of acceleration so obtained and shift this t to RHS and 30 times acceleration to LHS and you evaluate, you will get the value of t. Thank you, Team Educate.